Hi everyone, today's lesson is on sketching angles that are larger than 360 and also negative angles. So if we look at our XY axis, and you remember our lessons on angles and quadrants in the cast rule, we know that the positive x-axis represents 0 degrees, and then up at the top would be 90 degrees, and then the negative x-axis represents 180 degrees, 270 degrees, and then back to 0 is also 360 degrees. And then also, if we think about the halfways, they're good benchmarks for us. We know that this is 45 degrees, halfway between 0 and 90. And halfway between 90 and 180 is 135 degrees. Okay, you could think of it as 90 plus 45 if you want. And then 180 plus 45 is 225 degrees. And then 270 plus 45 is 315 degrees. So those are good angles to have in your mind when you're trying to sketch an angle in a standard position. Okay, so sketch each angle theta in standard position. Include the principal angle, which we're going to just use P dot A dot to represent. And I'm going to use a different color, so if you have a different color, that might be good if you're following along. And also putting alpha, which is that little acute angle between the x-axis and the terminal arm. Also include that in our sketch. So 510 degrees. So if we went back up here, we see that all the way around is 360. 510 is going to be more than that. But we want to know what quadrant. So again, if we go back up here, remember this was quadrant 1, quadrant 2, quadrant 3 down here, and quadrant 4 over here. So what quadrant is our terminal arm going to end up in? That's one thing we want to know. And we also want to know, is it going to end up being closer to the x-axis or closer to the y-axis? So I don't need you to use a protractor, but I want you to get the quadrant correct and then where it sits in the quadrant. So it'll either be closer to the y-axis in the quadrant, closer to the x-axis, or if it happens to be 45 degrees, it'll be right in the middle. Again, you're not using a protractor, but just trying to make a really good representative sketch here. So 510 degrees. So what we could do, if the angle is greater than 360, we can subtract 360 because that just loops us back around. So 510 minus 360 is 150 degrees. So our terminal arm of 510 is going to be in the same spot as 150 would be. And we know, based on what we were just talking about, that 150 is going to be in quadrant 2, and it's going to be closer to the x-axis than the y, because 150 is closer to 180. Or you can think of, if we have our benchmarks here, it's greater than 135, so it's going to be below the 135. Okay, so we're going to draw in our terminal arm closer to the x-axis in the second quadrant. Now, how do I show that it's 510 and not 150? Okay, so to show that it's 510, I'm going to start at the positive x-axis and go all the way around once. So that represents 360. And then 150 degrees more puts me at my terminal arm there. So that angle that I drew there kind of looks like a little spiral. That's going to represent my 510 degrees theta. Okay. Alpha is always between the terminal arm and the x-axis. It doesn't have an arrow. Alpha is always a positive angle. So alpha is always the difference, or the distance, sorry, between the positive x-axis and the terminal arm. So if we knew to draw this in the same location as 150, and this is 180, then we would know alpha was 30 degrees. Okay? Now the principal angle. The principal angle is the angle between 0 and 360. So let's do a little definition here. Principal angle. Angle, it has to be positive. So I should have put positive angle. Between 0 degrees and 360 degrees with the same terminal arm. So if you look up a definition, a math definition of what the principal angle is, it's the positive angle between 0 and 360 that has the same terminal arm, and in this case has 510. So that's going to be the angle that starts at 0. I'm going to use a different color for the principal angle. And then in the positive direction goes around to the terminal arm and stops there. So that's going to be my principal angle. And it's going to be 150 degrees. So the angle 150 degrees and the angle 510 degrees have the exact same terminal arm. Sometimes they're considered to be coterminal angles, or that's another term for them, coterminal angles, because they have the exact same terminal arm. So 150 degrees and 510 degrees have the exact same terminal arm. And the principal angle of 510 is 150. Okay, so that's how you would say that. The principal angle of theta, which is 510, is 150. And again, the principal angle is the positive angle between 0 and 360 with the same terminal arm. Okay, so again, we've got three angles on here. We've got theta, which is 510 represented. We've got alpha, which is always positive and is between the x-axis and the terminal arm. And then we've got the principal angle, which is between 0 and 360, positive, and has the same terminal arm as theta. Okay, so we're going to use a similar approach for 585. So first we want to see which quadrant it's going to end up being in. So I'm going to subtract 360 and see what that gets me. So 585 subtract 360 is 225. And if we look back up here at our benchmarks angles, 225 happened to be one of them. It's in quadrant 3, and it's exactly the halfway point of quadrant 3. So we know that that's where we're going to draw in our terminal arm. So we want to make it look like it's at the halfway point of quadrant 3. Do our best. Okay. Now 585 is bigger than 360, so we have to draw a positive angle. So we go all the way around one time, that's 360, and then over 225 more, so that we end up in quadrant 3. So this angle I've drawn here, this little spiral, is theta, which is 585 degrees. And then alpha is the angle between the x-axis and the terminal arm. So in this case, if this is 225, we figured out, and this is 180, then alpha would be 225 minus 180, which is 45 degrees. And then our principal angle is drawn from the positive x-axis around to the terminal arm. We use P dot A dot. Our principal angle is the positive angle between 0 and 360 that has the same terminal arm as our theta. So that's 225 degrees. All right. So here for the first time we've got a negative angle to draw, negative 120 degrees. So this is the first time we've had a negative angle. So still 0 is still going to be in the same spot, positive x-axis. So a negative angle, instead of going counterclockwise, you go clockwise. So this is going to be negative 90 here down at the bottom, negative 90 degrees. Then negative 180 degrees. So we're going this way around, negative 270. And then back to 0 would also be negative 360 degrees. Okay, so where would negative 120 degrees fit? Well, it's not going to be in quadrant 4, which is down here, but it is going to be in quadrant 3. And this would be, if you want to think about our benchmark, this would be, if we go back here, like negative 135 degrees. okay? So negative 120 is going to be closer to the y-axis. So I'm going to draw in my terminal arm here, closer to the y-axis in quadrant 3. So this is going to be my terminal arm, but I want to show a negative angle, so I'm showing it going clockwise. So this would be theta equals negative 120 degrees. Now alpha, just erase this for a minute, is always between the x-axis and the terminal arm, and it's always positive. So alpha is going to be this distance in here. So you can think about it in a couple of ways. If this is 90 and this is 120, then we know that this angle in here is 30, and a quadrant, a whole quadrant, is a 90 degree, so alpha would be 60 in this case, okay? Or you could do negative 180 subtract negative 120, and that would also give you negative 60, but alpha is always positive, okay? And then you would just write your 60 degrees in there. So we've got alpha and we've got theta, but we don't have our principal angle. So our principal angle is the positive angle, so positive, that has the same terminal arm as negative 120 degrees and is between 0 and 360. So it's going to start at the positive x-axis, go in the positive direction around to the terminal arm, and that's going to be our principal angle. So what is that angle? You can see that it would be the 180 plus the 60. 180 to here plus 60 would be 240. Is the principal angle. Another way of getting the principal angle is always the angle between 0 and 360. So in adding, so if you're at a certain terminal arm and you add 360, so say I'm here and I add 360, I'm just going to loop right back around here. So if you're at negative 120 and you add 360, you're going to get to the same spot. And that should give us, so negative 120 plus 360 gives me 240, which is my principal angle. Okay, so adding 360 just loops you around to the exact same spot again. All right, so negative 330. So again, we've got 0, negative 90, negative 180, negative 270, and negative 360. And then this in the middle of here would be negative 45. Middle of this one would be negative 135. Middle here would be negative 225. And the middle of this one would be negative 315. And we want negative 330, so we know it's going to be closer to the x-axis. And we know it's negative, so we're going to start at the positive x-axis and go clockwise around. So that's going to be theta, which is negative 330 degrees. Alpha is always positive. It's going to be this angle in here, which is 30. And then our principal angle, it does have an arrow, whereas alpha never does. So it's from the x-axis in the positive direction to the terminal arm. So in this case, the principal angle is also the same as alpha, 30 degrees. So the next one, 1020 degrees. So I'm going to subtract. We want to know again what quadrant we're going to end up in. So subtract 360. That's 660 degrees. That's still bigger than 360, so we're going to subtract 360 again. 300. So 1020 degrees is going to be in the same, or the terminal arm is going to be in the same location as 300 degrees. And we know that 300 degrees is going to be, so here's 0 again, 90, 180, 270, 360, and then the halfway here we know was 315. So 300 is going to be closer to the y-axis. So to get to the angle 1020, I have to go all the way around one time, there's 360. All the way around another time, there's 720. And then 300 degrees more. So there's quite the spiral. So this is theta equals 1020 degrees. So there's theta. Alpha is always between the x-axis and the terminal arm. So alpha is going to be, remember we said 1020 was going to be in the same location as 300, and this is 360. So alpha is going to be 60 degrees. And then the principal angle is from the positive x-axis around to the terminal arm. And that's where we figured out where to put our terminal arm. So our principal angle is 300 degrees. So again, we would say that 300 degrees and 1020 degrees are, oh, sorry, my bad. This should have gone all the way to here. So, sorry, 1020 degrees and 300 degrees have the same terminal arm. They would both be in quadrant 4, closer to the y-axis, 60 degrees away from the x-axis. Right, negative 660. So we want to know where it's going to be, end up, quadrant 1, 2, 3, or 4. Okay, so we can do that by adding 360 until we get to a number that's between 0 and 360. So if we add 360 one time, we get negative 300. And some of us might be like, okay, so 0, negative 90, negative 180, negative 270, negative 300 is going to be here, which is true. Okay, or some people might want to put it in terms of a positive angle, because then I guess you're finding your principal angle at the same time. So it's going to be at the same location as 60 degrees, which we know is in our first quadrant closer to the y-axis. But we want a negative angle. So here's negative 360, and then we have to go around negative 300 more, and that puts us at negative 660. So there's a drawing of theta equaling negative 660 degrees. Alpha is going to be between the x-axis and the terminal arm. So it's 60 degrees is alpha. And our principal angle from the positive x-axis with an arrow to the terminal arm is also 60 degrees. Okay, and G is 690 degrees. So this time we're going to subtract 360 to see if we can figure out what quadrant we're going to end up in. 330. So 330 is going to be in the fourth quadrant, closer to the x-axis. So 690 all the way around once in the positive direction is 360, and then around 330 more. So this is 690 degrees is theta. Alpha is the angle between the x-axis and the terminal arm. So this was where 330 is, and this is 360. Then alpha is 30 degrees. And then the principal angle is from the positive x-axis around to the terminal arm. So the principal angle of 690 is 330 degrees. Okay, now our second question here. It gives you a diagram and it wants you to determine the measure of the angle shown in each diagram. So the angle shown is theta in red here. And I guess you want to know, is the angle positive or negative? So this one, you can see it's counterclockwise, or sorry, it's clockwise, sorry. So it's going to be a negative angle. So theta is going to be negative. So I'll just put the negative out front of the brackets. And then how would I calculate this angle? Well, I know this is 0, negative 90, negative 180. But I would just leave the negative and say that if I go, then I know my angle is going to be negative, so the negative's out front. And from here to here is 180. But then I'm going to subtract off this 44 in here. So theta is going to be negative, and then I'm going to do 180 minus 44 and get 136 degrees. Okay, so I'm going to figure out the size of the angle inside the bracket and then just worry about whether it's positive or negative at the end. Okay, all right, so my next one, I'm going in the counterclockwise direction, so it's going to be positive. Okay, and then all the way around once is 360 plus, so then I'm thinking I'm adding on all the way to here, that's 180, but then I have to subtract off that 34 degrees. So theta is going to be positive, we know that, and then I'm going to do 360 plus 180 minus 34, or 506 degrees. So that's positive 506 degrees. So let's just do another one here. I'll just draw one right now. Okay, so my angle that I'm drawing is going to be, can't really use red, I'll just use pencil. Okay, so we're going to go there's my angle, theta, but then you're going to be told that this angle in here is 74 degrees. Okay, you want to pause the video for a second and try this, see if you get the right answer, and then once you figured it out, go back and see how you would do it. So if I was doing this one, I'd say, well, I know it's going clockwise, so it's going to be a negative angle. So all the way around once is 360. And then all the way around a second time is another 360. And then from here to here is another 180. And then this last piece is another 74. So that would be my thinking. So 360 plus 360 plus 180 plus 74. So it's going to be negative 974 degrees. Okay, so we've learned about how to draw angles that are larger than 360, how to draw negative angles, and then what is the difference between the angle, the principal angle, and then alpha, which is the angle between the x-axis and the terminal arm. So that's our lesson for today.